Okay, this question comes from the 2.5.2 worksheet, so the second worksheet I gave you in 2.5, problem number 11. And our directions right here are just to evaluate this limit right here, and we're not going to graph this one. So we didn't do one like this in the notes on 2.5, so a good question to ask. It involves everybody's favorite thing, complex fractions. So we're going to do a little bit of work to clean this up a little bit. And the key right here, and I think I can hear your groan already, guys. Nobody likes complex fractions. So we're going to try a trick right here to get this fraction not complex. We're going to try to combine the two terms in the numerator to get it down into just one fraction and then focus on something else at the same time. So I'm going to completely ignore this big fat X on the bottom for now and just focus on getting a common denominator in this fraction and this fraction right here. And to do that, guys, I'm not going to overthink this. I'm going to take the second denominator, which is 4, and just multiply that by both the top and the bottom of the first fraction. Then I'm going to take the first denominator, which was negative 4 plus x, and multiply that by the top and the bottom of the second fraction. Now this method that I'm doing right here is going to guarantee that you're going to get a common denominator, not necessarily the lowest common denominator, but I think in this case it will work. Okay, so where are we here, guys? And I'm sorry, I should have pointed out, does plug and chug work? Absolutely not, as it pretty much never does. So we are still evaluating a limit as x approaches 0, and now here we go. I'm also, though, guys, going to cut to the chase, and instead of drawing this again as two separate fractions, I'm going to show you guys right now, if I haven't already shown you in class by the time you see this, how this is going to work out. So let me show you what I mean by this. Okay, up in the numerator of the numerator, we've got a 4 times 1, which is going to give us a 4, and I'm going to write that right here. I'm not putting it in a fraction within the numerator. You'll see why in a second. And then plus this numerator times that numerator right there is going to be a negative 4 plus x. Let me rewrite that as an x and then a minus 4, okay? And that takes care of the numerator of the numerator. And I think you can see already something cool is going to happen with those 4s, but I digress. Now, I'm now focusing on this line right here, guys, what I would call the denominator of the numerator, which is just going to be the product of 4 times negative 4 plus x. Now I'm going to write that not as the denominator of the numerator, but I'm going to go ahead and write that downstairs in the numerator of the denominator, 4 times negative 4 plus x. I went ahead and moved that from the bottom of the top, the denominator of the numerator, into the top of the bottom, which is the numerator of the denominator. So the only thing I haven't covered so far is this x right here, which was the denominator, or the numerator of the denominator. That is going to go on the same line as everything else in the denominator here, and I'll put that x right there. It kind of builds off an idea, and I think I've discussed this in some cases. If you look at a complex fraction, guys, a over b, and if that all gets divided by c over d, I want to remind you guys that that is the same as taking a over b and dividing it by the fraction on the bottom, c over d, which is the same as taking a over b and multiplying it by the reciprocal of that denominator, d over c, so we end up with ad over bc. Now, if we ignore all of this junk and focus on how to go from here directly to here, let's take a look at what you see. The a, which is the numerator of the numerator, and the d, which is the denominator of the denominator, they end up together in your numerator. And then the b and the c in the middle, b being the denominator of the numerator, and c being the numerator of the denominator, they work together and they end up in the denominator of your fraction. I'm sure that made total sense. Okay, so back to this one right here. Algebraically now, we've combined the two fractions on the top and gotten rid of the complex fractions. Now, does this help us? Not at first glance, because when you put a 0 right in there, you're still going to end up with a factor of 0 in the denominator, which is still going to make your denominator become 0. But look at the numerator, guys. The 4s are gone completely. The only thing left in the numerator is an x, which cancels with this x down here on the bottom and just leaves a 1 in its wake. So now that that x in the denominator is gone, now plug and chug should work. We end up with a 1 in the numerator, And down in the denominator, we're going to take a 4 times, and then negative 4 plus 0 is just going to be a negative 4, and that should give us our answer here of a negative 1/16 for this limit here on problem number 11.